So this is the opening screen that we'll see in RSA. We'll go ahead and click this out. This will give us the most recent models we've done. But let's just start from scratch. First thing we can look at is the settings. So up here at the top, the settings. If you want to give the model a title, you can do that. The solutions, we won't mess with any of the defaults. The codes should be set up for you. These are the typical codes we're using, whether it's wood or concrete. So we've got the ACI 318 2014 edition, which is fine. So we'll go ahead and click out of that. Let's go ahead and apply it. In the 3D version, you can also list what the vertical axis will be. In the 2D version, you don't have a choice. The Y is up, X is to the right. So you'll see another option here in the 3D version. You can play around with that. Sometimes when you bring in a DXF file, it'll bring it in flat, or you want to bring it in vertical. So you just have to play around with your DXF file, or you can just change the orientation in the three-dimensional version. But we're not going to do that for this two-dimensional example. So a couple things we could do. We could simply just draw this by scratch. If we go up here to the spreadsheets tab, go down to joint coordinates, and if I wanted to, I could simply just type in the various coordinates, give you the model, kind of do it manually. Okay, if you had a very simple model, that would be easy to do. Oftentimes when we have more complex models, especially when you have, let's say, diagonal members and you want other members to connect to it, it's going to be very difficult to get all of your precise points, the geometry worked out by hand by doing the joint coordinates. So what I like to do is anything with any type of angles or curves, I'll bring that in with a DXF file. So let's go back up to here. Now, if you ever in one of these spreadsheets and you want to delete, you can simply just hit the F4. So we'll hit F4, hit F4, F4, and that just deletes all those. So I can X out of that. So let's go ahead and import a file. So I'll go to File, I'll go to Import. The only choice you have is DXF. Now what this will do, it will save a new model. So if you do open up the template file that I provided for you, unfortunately when you import the DXF, you're basically starting from scratch, but we can work through that. So we're basically going to be Xing out of this current model, starting a new model. Oops, my mistake. I don't want to do that. So it was asking me to save the model, which I didn't want to do. I just want to bring in a new DXF. So I'm not going to save what I just had up. So I'll bring in this one, this DXF, drawing 1 DXF. So I'll leave this as the defaults. When I drew my model in AutoCAD, I was working in the architectural units. So if I bring it in just with the default, it will put it in the right units. Again, you may have to experiment around with that. Make sure when you bring in your DXF file, it is bringing in the right units. Obviously, if you're off by a factor of 12, meaning you're going to bring in inches versus feet, you'll find out pretty quickly. Now, what we can do, if you draw everything in your AutoCAD file on one layer, it's just going to bring it in as one, basically everything on the same layer. It'll be the same shape. If you get a little bit more advanced, you can actually assign various pieces within RSA. I'm going to go ahead and skip this because our models are going to be small enough that we'll just do this manually by hand. So don't worry about translating this layers to section sets. translate layers to shapes. Again, if you got a little bit more advanced, you could do that and save time on a very, very complex model. So I'll just say go ahead and OK. All right, so it brought up the global settings again. So if you want to type in ARC 335, put your name in here. The codes, those are the defaults. Those are all fine. Click out of that. So this brings up the DXF file that we drew in AutoCAD. And again, one of the reasons we do that, if I would have drawn this point in RSA and this point, and then I was trying to draw a point across, you'd have to get very precise in terms of your geometry to figure out, well, what is that point? Where is that going to occur on that sloped line? In AutoCAD, it's pretty easy, right? We draw a line, we just trim it off, and now I have a perfect intersection point right here. So again, could I do this in RSA? Yes, just a lot more time consuming to do that. So a couple things here that are maybe a little bit messy, a couple extra pieces that I don't want. If I go up here to this icon, this is the draw icon or the graphic editor icon. So if I click that, it's going to bring up a number of possibilities in terms of graphically drawing this model. And one of the things I may want to do is erase things. So this is this X icon right here. So if I click on that, apply, and I can go in here and erase a couple of these extra things. And this is also a construction line here. I'm going to erase this because what I'm going to do here is just drawing a simple gable roof, but I've moved the tie. Instead of being down here, let's try it with the tie moved up slightly. We call that a collar tie in wood framing. So that's the graphical editor, right, that you can bring up and use this to erase. Now, another thing that you want to do is what's called a model merge. Even though you think you've drawn it very accurately in AutoCAD, sometimes you may get two items coming together that maybe don't touch. Maybe you have multiple things drawn on top of one another. And with the model merge, it'll kind of clean that up for you. It will clean it up for you. So if I go here to Tools, Full Model Merge, crossing members, inactive items. So we'll go ahead and apply. Well, I was pretty good with my AutoCAD, so there's nothing that has to be merged. So this is just a good way to clean up a file because you think it's so drawn accurately, but the program will check it for you. So looks pretty good. So let's move into adding support conditions. So again, I can toggle this on and off, toggle it back on. The support condition is listed right here. Now, another way to do this would be to go to the spreadsheet. So you can do everything by spreadsheet here. So if I wanted to do boundary conditions, I could type it in here for joint 3, joint 4, or I think it's easier to do it graphically. So I'll click that. And it gives you different choices: free, which is the default, fixed surface, pinned, or roller. So what I typically do when I model some type of a truss or frame, that I will model one side to be fixed and the other side will be a roller connection. So basically the frame itself is doing all the work. And I'll put a roller on that side. So the idea for the truss is as I put load on this thing, it will try to spread out, right? It'll try to push out. So if I put a fixed condition here, that's really not how it's going to act in reality. Typically, we're putting a truss on top of a wall, putting on top of a column. The column really doesn't have any manner to resist that outward thrust. You want the truss to actually do all the work. Now, if you're doing a moment frame, let's say like Crown Hall, in that case, we would pin both sides of the frame. But for the truss, I'll put a roller here and I'll put a pin on that side. Next thing that I want to do is what are called section sets. Now, this was set up for you in the template file, but because I brought in a DXF, I've got a new file, so I need to create those again. The materials, you shouldn't have to worry about those. Any materials that you'd be using are pretty well listed here. Obviously, you can add, however many materials you want, even within steel. There's additional steels we could add, additional concretes. There's only concrete 3,000 through 4,000, so we could obviously add 5,000, 6,000, whatever strength we needed. But for this assignment, just using one of these defaults like the 4,000 would be fine. I'm going to do wood, and it's got various different woods listed here. Again, there are infinite amount of types of woods that I could put into the program. They're actually built into the program, but we're going to go ahead and use those defaults. So back to spreadsheets, materials, we just went through that. Section sets. So this is a way to define, let's say, a column or a beam, and then I can have multiple members within your model being the same section set. So I'm going to go to wood, and I'm going to call this rafter. And I'll call this one tie. And I'll keep both of them at a 2x6. Now, if I wanted to change the rafter, let's go ahead and do that. So I click on that, and these are other options that I can use as well. If I want to change the material, I could do that as well. So you may have a model that has, 100 different members, and they're all called rafter. So they're all the same. And what that means then is I could change all 100 of them at one time by just going to the rafter within section set and then change the shape, or I could change material. I could use a steel material. I can make a larger section, whatever I want to do. So it just makes it easier to edit things. It's like you're editing one, and that's going to take edit all those that are called by the same name, in this case rafter. So if I go back up to the spreadsheet, next thing I'll do is go down to members. Now, because I didn't assign any of the layers to section sets, I just brought the DXF file in. I was essentially just using it for geometry. So it's got the various members in. Let me do one more thing. If you hit the F2 key, and that's a very important key to learn. So I hit F2. That brings up a dialog box that I can use to select what I want to see on the model. So in this case, let's say members. It's a wireframe. I want to bring up the label. So this then tells me, well, that's M2, that's M5, that's M3. If you remember, I did erase some members, so that's why the M1 is gone here. What else? M4, I guess, was along here, and I erased those. So now I know which member's which in terms of the labeling. So I go back to members. So M2, so this is the generic shape that RSA just assigned to that piece. I want to change that, so I click that. I go to wood, and this is the one that I put in. So I want to assign a section set. If you wanted to assign each one of these individually, you could do that here. I again like to work in section sets. If I did this, I could go in here, and then I could choose the one for each individual piece, right? Let's not do that. Let's assign a section set. So I want the M2 to be a rafter. I'll do the same thing here. Say I want it to be wood. I'll use the section set, and I'll call that rafter. And then M5, that's my tie. So again, go to wood. So if let's say I clicked on hot rolled, so that's a different section set, right? So I could define various section sets for steel. I could do the same thing for cold form steel, same thing with concrete. So I just worked with wood. I just created these two different types in wood. So I go to tie, I say okay. Okay, so that changed the material. So now they're all Douglas fir material. Don't worry about the type. We're not going to get that advanced in the program. Let's click out of this. Let's go to F2 again. Let's make sure we've drawn it correctly. So F2. And excuse me, what I'd like to do here is render it. I want to see if I've drawn it correctly. So that shows the piece. Now what's even better, I hit ISO view. Yep, and that shows me that the deeper part of the piece is oriented in the north south, or the up and down axis, or in the y axis. So that's helpful to toggle between those. The other thing it's doing, it's only going 80% of the length. If you wanted to go the full 100%, hit F2. You could change that to 100% if you wanted to. That goes to the end. Okay, so let's go back and change that to 80%. Okay, so I'm going to stop here, and then I'm going to create another quick tutorial about entering loads and solving for the problem.